The transform widget is, in my opinion, one of the most powerful visual widgets in Flutter. It allows us to perform various mathematical operations to a widget, such as translation, rotation, scaling, and more. The simplest variations of these are given by the associated constructors. Underneath the widget itself, a 4x4 matrix represented by the Matrix4 class holds the actual transformation values. To utilize the full power of the transform widget, we need to understand how this matrix works and in turn modifies the child widget. Hopefully, this doesn't get too mathematical. Let's begin. The translation operation moves the entire widget by the defined distance. The easiest way to do this is to use the transform.translate constructor, where we can define the translation along the x and y direction. Note that the top left is the origin and downwards is the positive y direction for any operations. Now, let's try this using the 4x4 matrix. The matrix on the screen is called the identity matrix. It is the matrix equivalent of the number 1 and does not change the child widget in any way. To apply translation along the x, y, and z axes, we change the first 3 values of the last column of the matrix. The Matrix4 class also has a set translation method which can set these values without modifying the matrix entries. Scaling increases the size of the child widget in one or more directions by defining a scale factor. A scale factor of 2 means that the child will become twice the size. The transform.scale constructor allows us to define the scale across the x and y axes using the scale x and scale y parameters, or together using the scale parameter. In a 4x4 matrix, scale values for each axis are defined across the diagonal. However, the fourth value on the diagonal can also define the reciprocal of the scale factor for all axes. The Matrix4 class has a scale method which can set the appropriate values as well. The best way to define shear would be that it tilts the shape without changing the area of the object. The shear operation tilts the shape by changing one of the 2 axes. Hence, there are 2 possible shear types for every axis. Since we have 3 axes, there are a total of 6 shear types, but we are only working with the x and y axis. Hence, only 2 types are available, xy and yx. The only way to do this is to change the values 0, 1 and 1, 0 for the xy and yx shear respectively in the matrix. I saved rotation for later since it is the most complicated of the possible operations, even though it definitely doesn't seem like it from the user side. The transform.rotate constructor is an easy way to perform a rotation with respect to the z-axis, since that's the axis coming out of the screen. While translation, scaling, and shear in the Flutter context do not need to deal with the z-axis, rotation does. Rotation can be performed with respect to any of the 3 axes. While the other transformation properties depend on singular values in the matrix, applying a rotation requires 4 values for each axis as shown. There are also set rotation functions in the Matrix4 class, which help set the respective axis rotations. In my own experience, the 3D perspective transformation is one of the best transformations available to us. If you look at a plane placed at an angle right in front of you, you will notice that the side closer to you is larger and the side away from you is smaller. To define this more accurately, any parts of the object away from you on the z-axis shrink, while the parts closer to you scale up. This makes 3D effects easily doable, even when working with a 2D surface. Similar to Shear, there is no good way to add 3D perspective via the Transform widget or the Matrix4 class. If you have ever seen this line in tutorials working with transforms, you may have wondered what it was. This value in the matrix sets the amount of scaling that occurs in the z direction. If you have guessed the pattern from the other transformations, this also means that there are similar operations for the other axes, and indeed there are. Drawing some parallels to the first transformation, we can define this as an operation which changes the scale of the object uniformly along an axis. That means, in the other two transformation types, the object shrinks as it goes along the x or the y axis. Here are the values of the matrix we need to change for making this possible. While the z-axis value is useful to us for 3D transformations, I have not yet come across good uses for the other two axes. Feel free to send me examples you've made with those. Thanks for watching this video about Flutter transforms. While I'm more of a writing person, I felt there are some concepts better explained through videos and animations. Check out my other channels for more articles and experiments I make, and I'll see you next time.